All right, out of my comfort zone a little bit, talking a little bit more about physics than math here. And a student had asked me for a little bit of help with this. So they're dealing with math, but really I think this is a little more physics. So let's just kind of dive in here. I'm going to try my best here. If you please feel free to ask me any questions. It's been a long time since I've done this, and yeah, so I'm qualifying my answers here a little bit. But any questions you have, please send me along the way. All right, a couple things we need to go through first. First, the idea of a revolution, right? So the idea of a revolution is something kind of going around in a circle, right? And we're going to talk about how long it takes. Sometimes we measure it in seconds, sometimes we measure it in minutes. But the idea is, something traveling around in a circle, around and around, okay? And right now, since I'm going counterclockwise, we're going to talk about that in the positive direction, and if you were to go the opposite way, it's the negative direction, okay? So we'll stick to that right now. That's the general idea. I'll talk a little bit about this idea of radians, right? So radians are a measure that we use to determine how much of a circle something has gone by. So real quick reverse explanation of this is, the idea is what happens if you travel the distance around a circle, right? So let's say I'm going to travel a distance around the circle, and that's going to be this yellow piece here, okay? So this is how much of a circle I travel if the yellow piece right here, this piece right here, this is also the same length as the radius, okay? That's the general idea, okay? So that this distance here is going to be r, which is the same as this green distance, which is r, which is the same as this distance, which is r, okay? That's 1 radian. So if I were to take the radius here and I were to measure this same distance here, that's what a radius is. I mean, a radian is, okay? And the terms are obviously meant to be the same idea, right? So if I talk about, and that's an angle measurement, right? So that's the amount of an angle, like how much of a circle it travels, right? And that's assuming that, the generic term we use for angles is theta, okay? That's this one, theta, okay? So what we want to talk about is, okay, how much does it actually go, right? And so if you went all the way around the circle, the circumference of a circle is going to be 2 times pi times radius, right? So the distance around this whole circle all the way around here, like this, okay? This is going to be, if I travel all the way around this way, it's going to be 2 pi radians, okay? Right, because I would have traveled that much of a distance, okay? So 1 radian is this angle here, that angle here, theta. Right, in here, this angle here, that's going to be 1 radian, okay? Now, you can also look at it as saying this is the same as 360 degrees, okay? And so halfway of the circle is going to be pi radians, okay, or 180 degrees, right? So it's really just this idea of this unit, right? It's a unit that you just have to get used to. People use it, mathematicians use it. You just got to keep going, right? You probably are pretty familiar with degrees. 180 degrees, you can envision that. So now what you need to do is start converting that, get yourself used to pi radians means half a circle. Same idea as 180 degrees. 2 pi radians, 360 degrees, right? Pi, half of pi radians, 90 degrees, okay? Or a quarter of a circle. So that's the general idea, all right? It's because what we're going to talk about here is we're going to talk about angular speed versus linear speed, okay? So the general idea of angular speed says how much of an angle, okay, how much of the angle am I rotating around the center given a certain amount of time, right? So like how long does it take, right? Let's say that was 1 second, okay? Well, how much of an angle did I go? Like 360 degrees, right? If I go 360 degrees in 1 second, 360 degrees, 1 second, 360 degrees, 1 second. But what we need to do is we need to say, okay, instead of 360 degrees, okay, per second, we're going to do it in radians, okay? So that's what we're saying here is we're going to say that's 2 pi radians each second. These are equivalent, same idea, okay? So 360 degrees, full circle per second, 2 pi radians, full circle per minute, same idea. Okay, now why do we want to use angular speed as opposed to linear speed? So when you have things that are rotating around, right? Like this whole line is going around, okay? But if you notice here, if I go around this way, and let's say both of these are traveling in 1 second around, right? You can say that they have the same angular speed. But if I were to superimpose these on top of each other, in fact, let's go ahead and do that. Let's just kind of play around with this, see what happens, okay? If I were to take, come here, come on, come on. Why would it move? It's not liking this. All right, well, let's say, think of this. Let's say you had another dot on here, right? If you were to spin this thing around, okay, let's see, let me get both of these together. Okay, if I'm going to spin both of these around, well, it's not going to follow, but think about that dot on that line, okay? If you were to travel around in 1 second, that inside dot doesn't travel anywhere near as far as this one, right? On the outside, it's going to go much, much, much further in the same amount of time. But that's where it gets confusing, right? Every point along this line is going to have a different distance that it travels. So that's why speed in a linear sense is really difficult when you start talking about rotations, right? Like these two circles here, right? This circle and this circle have two different circumferences, okay? The distance around them is completely different, okay? But if I go around 1 second here and I go around here in 1 second, the distances they travel is going to be a different amount, but the angle that they travel is the same. And that's the part that we need to keep in mind. All right, from there we got to worry about unit conversion. And this is a sort of this, I guess, a trick one of my teachers when I was in high school used to use. A lot of it was just setting up the unit conversions the way that you need to, right? So if you're going from, like, let's say meters per second, and you need to go to feet per minute, you use your unit conversions, right? You know how the units need to be set up, and we're going to set them up so that the units cancel themselves out along the way, right? So if we said, okay, we need minutes, right, and we need that to get compared to, let's say, what do we need to do here? Feet per minute. Minutes, if we need to convert it, so we can do like 60 seconds per 1 minute. And then what we can do is we can say the seconds, right, cancel out with seconds, and we end up getting closer to feet per minute. That was a terrible example, so let's just move on. You'll see what I'm talking about here in a second. All right, let's do some more actual explanation here. All right, so here's a problem. We got a diameter of each wheel of a bicycle is 26 inches, right? So diameter. So diameter is talking about straight across. So this is 26 inches, right, from side to side. All right, so which means that my radius is going to be 13 inches. Okay, so from here we're going to look at this and we're going to talk about, we want to convert this to see how many revolutions per minute this thing is traveling, right? So I gotta take a look at my notes since I had to solve this one earlier. All right, so ultimately what we're trying to do here is we're trying to end up with, I'm going to put it way over here, right? We're trying to get to miles per hour. So this is what we need it to look like. Okay, so right now all I know is that the wheel is 26 inches in diameter. Okay, this means my circumference is going to be 2 pi r or pi d, right? So I'm going to say my circumference is going to be 26 times pi inches, right? That's the distance around this circle, right? So for the tire to touch the pavement, right, one full rotation will cover this much, right? Will cover that much area, okay? So really what we know is we know that we're going to have 26 pi inches per revolution, right? So each revolution is going to be 26 pi inches. Now what we need to do with this is we need to convert this to miles per hour. All right, so, well, in this case, we know that it's actually 25 miles per hour, right? And so we want to know how many revolutions per minute we're going to do. Okay, so we have 25 miles per hour, and what we needed to get it to is basically inches. Let's see, we need to convert it to inches so that we can find out it is per minute. All right, so we know that we've got 26 inches per revolution, okay? And we're doing 25. We know we have 25, okay, 25 miles per hour, and we need to end up with, at the end, we need, okay, we have this, we need minutes. Okay? How many revolutions per minute? Okay, so right now, the way I have this written is the revolutions is in the wrong spot, right? So I need one revolution, okay, in 26 pi per 26 inches, pi inches. All right, so then when I'm going to look at this, I'm going to multiply, okay? And so at this point, I know I've got 25 miles per hour, so I'm going to put that in there, right? And so since minutes is on the bottom, right, well, let's see, we can do 1 hour, right, because we're going to do hour, and we need 60 minutes on the bottom, so I'm going to do 60 minutes here, okay? And then I need to know, let's see, I've got one revolution, inches, I need to get, in revolution stays, minutes stay, so I need to turn inches into miles. Okay, so I'm going to put inches on top, okay, and I'm going to do miles on the bottom. Okay, so how many inches are in 1 mile? Well, I know that there's 12 inches in a foot and 5,280 feet in 1 mile. Okay, so that's how many inches are in 1 mile. Okay, and then what I can do is I can multiply that times 25 miles, right, per hour. And let's see if that's going to get me to revolutions per minute. Okay, so I've got inches cancel with inches, and miles cancel with miles, and hour cancels with hour. And what am I left with? I'm left with revolutions. Let's see. And minutes, okay? And that's what I need. I need revolutions per minute. So then if you go ahead and you multiply, right? So I'm going to do 12 times 5,280 times 25, and then I'm going to divide that by the combination of 26 times 60. All right, and let's see. What did I end up getting? I think I got 323 revolutions per minute, okay? In fact, let's go ahead and we'll just pop out the calculator here real quick. Let's see, math tools, calculator. All right, so we got 12 times 5280, okay, times 25 equals, okay, so that's the number of revolutions, but then we have to divide that by 26, okay. This isn't scientific. I don't have a pi function on there. All right, so we'll divide it with that. And I'm going to divide that by, we'll do 3.1415 equals that. Then we'll divide that by 60. And I get 323. There we go. 323 revolutions per minute. Okay? And we could convert that. We could turn around and do it the other way, right? We could do 323 revolutions. We could multiply that by 26 pi and convert it all the way back to see if it gets us close to 25 miles per hour. It won't be perfect because I rounded this, okay? But here's my final answer there. All right. Hopefully that helps. Let's keep going. Object is traveling around a circle with a radius of 5 centimeters. If in 20 seconds the central angle of 1/3 radian is swept out, what is the angular speed of the object? Okay, so right away we know, let's see, this is going to be pi, this is pi over 2, right? So let's see, if this is pi, then I need to break this up into thirds. So we're going to say that's about 1/3 of a radian, okay? This is about 1/3 of a radian. Okay, so we're saying it's traveling, let's see, if in 20 seconds the central angle is 1/3 radian, okay, so let's say in 20 seconds, so it's going 1/3 of a radian in 20 seconds, okay? Well, 20 seconds is 1/3 of, this is the same as 1/3, wow, whoa, sorry, 1/3 of an hour, or a minute, sorry. So what I'm going to get here is it's really 1 radian per minute. Okay? So then an object is traveling on a circle with the radius of 5 centimeters. If 20, what is the angular speed of the object? Okay, so we know it's 1 radian per minute. So then what's the linear speed? Okay, so we want to know how far does it go in 1 minute? Well, 1 radian, right? 1 radian is going to be, the distance of 1 radian is pi, right? So it's going to be pi radians. Okay, I'm sorry, pi. Sorry, in this case the radius is 5, right? So let's see, 1 radian in 1 minute. So if it's going to go 10 centimeters, right? Because if 1 radian per minute, now it's going to go, I got to check my notes again. Sorry, brain fart. It's going to go 5 centimeters in 1 minute. Okay, how did I get this? 1 radian, right? Remember, radian is this distance here. It's the same as the radius. Okay, so it basically sort of, if you think of this as kind of being like an equilateral triangle, except this is a curve, then all of the sides are the same. So the radian here is the same as the radius, which happens to be 5 centimeters. Okay, so there's your linear speed. All right, let's do one more here. Uh-oh. Okay, here we go. A record is spinning. A ladybug lands on the turntable 10 inches from the center. At what is okay? What is the linear speed in inches per minute of the ladybug? Okay, when the turntable is set to 33 RPMs. Okay, so we know that this ladybug is. We know that from here to here is 10 centimeters. Okay, we know that this thing goes 33 revolutions per minute. Okay, so then how long is a revolution? Okay, we know that 1 revolution, right, is going to be the same as 2, or it's going to be, in this case, 2 pi r. So we know that centimeters, which is going to be 2 times pi times 10, so 20. So we know it's going to go 20 pi centimeters each revolution. Okay, so then what we want to do is we want to find the linear speed. So after, let's see, in 1 minute, how far will it go? All right, well, we know that it's 33 revolutions, right, per minute. And we want to know, okay, so then we just convert it to a distance. So we know it's 20 pi centimeters per revolution. Okay, my revolutions cancel out, and I get 660 pi centimeters per minute. Okay, and if you could multiply 660 times pi, and you'll get, I don't know, probably around 2,000 or so centimeters per minute. Okay, hopefully that makes sense. There's another problem sometimes where the ladybug moves back in towards it. All it does is it just changes the radius, right? Like maybe it moves in 3 centimeters and now your radius is 7. So instead of this being 20, right, your radius changes. It's now just going to be 2 times 7, right? There's a smaller distance that it goes around now, so it doesn't travel as far. So it's going to be, 2 pi d, or 2 pi r, so 14 times pi instead. Okay? Sorry that was long. Please, if you have any questions, let me know. Hopefully that helped, kind of.